Welcome back. In this video, we are going to discuss about the K-means concept under the clustering techniques. What is meant with K-means? The K-means is the most popular clustering algorithm, and it will use the partitional and prototype-based clustering methods to ensure the cluster validity and clustering techniques. And it represents the kind of center of gravity for set of instances. And basically, we use the hyperparameters to choose the objects and finding the distances and forming the groups. It will use the centroid and distance measures to measure the distances between the objects. The centroid, it is a prototype or profile of all the objects in a cluster. For example, the average of all the objects in the cluster is considered as the centroid value. As if we have several photos of cats and dogs, then if we put all the dogs and in one cluster and cats in the another cluster, the dog and cats grouped based on the appearance of the images. Then the centroid of the dog cluster, it will be considered as the photo representing the average features in all dog photos. We can observe that the centroid of a cluster is not usually one of the objects in the cluster. This is the algorithm how the k-means is get working. First, we have to give the input of in data set, and from that we are going to measure the distances, and we are considering the number of clusters. It is represented in k. And first we have to define the k value centroid. Then after that, till find grouping the all the objects in the cluster, we will repeat. And next we have to associate each instances in data set that is very closest to centroid according to the chosen distance measures p, and recalculate the centroid using all the instances from the data set associated with it. And this will be get repeated until the no instances from the data change the association. Partition algorithm. First, we have to decide the value of k, initialize the centers, cluster centers, decide the membership, and then re-estimate the cluster centers. Then, if none of n object is changed, change the membership last iterations. Otherwise, we have to go to step 3 and we have to form a membership. And this is the step 1. Here we are finding the centroid value K1, K2 and K3. Then we are performing the partition of K1, K2 and K3. Then after that we are calculating the distances. We are applying the different types of distances in the each centroid. Then we are moving the that particular cluster head into near to the objects in the cluster. Then we are finding the nearest value, and next also we are finding the distances. Here also we are finding based on the distance metric, that is equivalent distance. Then next one is the strength and weakness of the k-means. The strength is relatively efficient if where n is an object, then k is a cluster, then t is a iterations. Then it will be represented as cluster, comma iterations, which is less than to a number of objects. Then the terminates all at a local or optimum. The main weakness, applicable only when mean is defined. Then what about the categorical data? Need to specify k, the number of clusters in advance, unable to handle the noisy data or outliers, and it is not suitable to discover clusters with non-conventional shapes. Thank you. Reference.